Good afternoon, class. We are looking at practice test for pre-calculus, module 1, covering chapters 1 and 2. Here's chapter 2, linear functions. Extrema. Local or relative extreme values. Extrema is the plural of the Latin extremum. A local minimum is the minimum value within some open interval. Local minimum occurs at a point C in an open interval of A to B in the domain if f of c is less than or equal to f of x for all x values in the open interval. So peaks and valleys are local extrema. This is a local mean. This is a local max. A local maximum is the maximum value within some open interval. Local maximum occurs at a point C in an open interval of A to B in the domain if f of c is greater than or equal to f of x for all x values in that open interval. And again, same shape, local mean, local max. This is the smallest value in some open interval. This is the largest value. So look at peaks and valleys. What about absolute, also known as global extreme? Values for extrema are either maximum or minimum points on a curve, meaning in the entire domain. Absolute minimum occurs at the point C if f of c is less than or equal to f of x for all, and that's the key. Not in an open interval, but rather for all x values in the domain. So local mean, local max, local mean. This local minimum is also absolute minimum because no other point has a smaller y coordinate. Absolute maximum occurs at the point C if f of c is larger than or equal to f of x for all x values in the domain. Again, local max, local mean, local max. This local max is also absolute because no other point has a larger y coordinate than that. Extreme value theorem, if f is a continuous function whose domain is a closed interval of A to B, then f has an absolute max and an absolute mean in the closed interval of A to B. What it says is, we happen to have a closed interval, it must, and it's continuous, it must have an absolute max and mean somewhere. It could be that it's the endpoints. All right, let's look at this example. The graph is given. Use the graph to estimate the interval where the function is increasing or decreasing. So reminding everyone that a function f is increasing on an open interval I if for any choice of x sub 1 and x sub 2 in I, with x sub 1 less than x sub 2, we have f of x sub 1 less than f of x sub 2. A function f is decreasing on an open interval I if for any choice of x sub 1 and x sub 2 in I, with x sub 1 less than x sub 2, we have f of x sub 1 larger than f of x sub 2. What does it really mean? This says, okay, as we go from left to right, x increases, right? If the y increases also, that's increasing. If y decreases, it's decreasing. It's that simple. So for this, looks like a line with a positive slope. For this, looks like a line with a negative slope. And of course, a function f is constant on an interval of I if for all choices of x in I, the values of f of x are equal. In essence, a portion of a graph which is a horizontal line. So where is this increasing? We should see that this portion is increasing. This portion is increasing. And this portion is from -8 to, this seems to be at -3. Union from here should be from 3 to about 7. And the endpoints are not included. We put the union. Where is this decreasing just from here to here? This is the decreasing part, everybody. From roughly -3 to 3. This is an inequality format. This is an interval format. The endpoints are not included. Okay, we don't include the endpoints. It used to be the case. You don't have to worry about that nowadays. Determine any local maximum or minimum value. This is the local max, this is a local mean, and local max is equal to 50 at x equals -3, so -3 comma 50. This should be the local mean, which is equal to -50 at +3 negative. So this point and this point, again, doesn't show good. This didn't work out good here. Not that. And here. So local minimum equals -50 at x equals 3. So we're talking about this. Okay. When we look at this concept, everybody, please understand, we mean, when we say local max, we mean the y coordinate of the function. Determine any absolute max or minimum. Local max, local mean. This is the absolute minimum. This is the absolute maximum. Absolute maximum seems to have a y coordinate 150. So absolute maximum is equal to 150 at 7, 150. Absolute minimum is maybe about -225 roughly, or -215. So the y coordinate, you read it. And it seems to be at roughly -8. Okay. So this, again, this is not correct, everybody. Maximum is 150. This is the point. Okay. And this one is the absolute minimum. Again, I'm reading -225, but it may be just a tad different. For the following function, find f inverse of x. F of x is given as 2x minus 7. So to find the inverse, the very first step is to change this to y. The second step is to interchange x and y. The next step is to solve for y. We are going to move the -7 to the other side. So add 7 to both sides. Then we're going to divide both sides by 2, and we give it the name F inverse. We're done, but it's a good practice to prove that, and to prove it is by the composite function with the inverse, meaning f of F inverse or F inverse of OF equals X. And we can look at one of them is good enough. I'm going to look at one, and I highly recommend you do the second one for definitely practice, everybody, okay? I highly recommend that. F of F inverse of X. So replace the X with this piece. You get X plus 7 minus 7. We cancel each other, we get X. And that's the proof. Very straightforward, everybody. Look at this function. F of X is X over X plus 2. And we are to find F inverse. So the very first thing we do is to change this to Y. Again, the reason is because it makes it easier to work with that. Interchange X and Y. That means this is X now. This is both of them change to Y. Multiply these two. X times Y plus 2X equals Y. Cross product, everybody. Cross product. You're solving for Y. That means you want to move things around and make sure all the Y's are next to each other. It doesn't matter how you move that. And on the right side, we can factor the Y out. And divide both sides by 1 minus X. We are done. We change the name to F inverse. Now, one thing I want to make a point of, the way you move things around, you may end up with this or this. Please understand that if you multiply this one by negative and the bottom by negative, you get this one. I wanted to get to the least number of negative side. Okay. Now, let's prove that by looking at f of F inverse, which means replace the X with either this or this expression. So let's do that. Now we are looking at a complex fraction. The only denominator here we have is 1 minus x. We're going to multiply the top and the bottom by it. So that is the LCD we need. So what happens when we multiply the top by it, 1 minus x goes away. So the product of these two is just the numerator 2x. But what about these two? The same thing, 2x and then plus 2 times 1 minus x. In other words, when we multiply these two, we just get the top, the same thing here. And then don't forget plus 2 times 1 minus x for the denominator. Now you are going to distribute, you get 2 minus 2x. These two cancel each other. So you have 2x over 2, which is equal to x. Use function composition to verify that f of x and g of x are inverse functions. Remember, two functions are inverse of each other if their composite function is equal to x. So we are going to look at their composite function f of g of x. By the way, it doesn't matter in what order. F of g or g or f of x should be the same thing, x, because they are supposedly inverse functions. We don't know that. We're going to prove it. So what is f of g of x? Just replace the x here with the g function. Still cancel each other. Cube root of x cubed is x. Now, we're done, but just quickly, if we want to show GOF of x equals x, replace the x with this. So when you do that, you get cube root of x minus 1 cubed plus 1. So this comes out as x minus 1. Two cancel each other. 6. Either way, we prove that. And again, you don't have to do both. One is enough. Sketch the inverse of the function whose graph is shown. Well, draw the line y equals x and reflect the graph on the line. Because remember, two functions are inverse functions. They are symmetric with respect to the line y equals x. So how do we do that? We draw that, and then all you have to do, pick up a few easy points, okay, from the graph. So this point, -2, -4, is an element of, remember, this is red, looks like an epsilon. This symbol in math is red, an element of. So this belongs to f of x. In other words, f of -2 is -4, and the inverse contains -4 comma -2. So that's the meaning of this two are equivalent. So that means f inverse of -4 is -2. Or even if you don't want to write that, say this point is on the function f of x, then -4, -2 is on the other one, the inverse function. So we go 4 to the left, 2 down, and that's the point we are looking. Let's pick another easy point. The y-intercept has coordinates 0, 4. So 0, 4 belongs to the function f of x, is an element of the function f of x. If we want to go with this process, that means f of 0 is 4. And that means f inverse of 4 is 0. But like I said, 0, 4 is on f, then 4, 0 must be on f inverse. You can go directly from here to here. You don't have to, but this is just to understand the meaning of each case. So 4, 0, 4 to the right on the x-axis, that belongs to its inverse. Let's look at another easy point. This point has coordinates -1 and +3. So right away, 3, -1 is for the inverse function. But what does it mean? F of -1 is 3, and f inverse of 3 is -1. And as I said, you can go right from here to here. Now 3 to the right and 1 down. Again, if it's enough, so be it. If it's not, you pick more points, okay? So this point, this point, this point, so you go like this. And by the way, anytime there is a point that one of the graphs touches along the line y equals x, so does the other one. Why? Because x and y are interchanged for the functions that are inverse of each other. So x of this is y of that. And that's if one of them has a point that crosses the line y equals x, that's the point that x and y are identical. So therefore, it must belong to the other graph as well. And it does. Sketch the graph of the function f of x. Evaluate a few points and determine the domain and range. So what we are looking at is called piecewise defined function, because there are pieces. How many pieces? In this case, we have one piece, second, and the third. We have total of 3 pieces. And so what I suggest is that you do all those 3 pieces without paying any attention to the limitation. However, just to make it easy, let's just pick up a few points just for the sake of argument. This is good from -1 to 1. So if I want -1, I have to put it in here. And that gives me +1 and 1, 2. If I want a 0, I put it here, I get 1. If I want 1, it becomes 0. Now, at x equals 1, actually, if I want 1, I get 2 because it doesn't have the equality. But it's supposed to be 0 if they are supposed to come together. When x is larger than 1, for example, 2 is 4, or 3 is 9, or 4 is 16. So those are a few points that we should know. Again, just in case. -1, you use this one. 0, you use this one. 1, it's given. This means the pair 1, 2. 2, you use this one, you get 4. 3, this one, you get 9. So those are a few points, and you can plot those pairs and they will help you see the graph. But for now, here's what I mean by graphing all those pieces, starting with the top one. Y equals negative x plus 1 is a line that contains the two intercepts 0, 1. So this one is 0, 1, and this one 1, 0. And so we can locate the 2 points. And this is 0, 1. This is 1, 0. That's a line. Again, for now, I'm not paying any attention to this one. I'm just drawing this line. Then this one, f of x equals 2, that means y equals 2. It's a horizontal line, okay? But because it's good at 1 point, let's just do that 1, comma 2, just 1 point. So that means 1, comma 2. So I want to show you here that this means this point. Point 1, comma 2. Now, y equals x squared. As you know, it's a parabola that goes through 0, 0. Again, let's not pay attention to that. Let's graph that. Parabola y equals x. Okay. Now we want to pay attention to the restrictions. Starting from the top, it says it goes from -1 to 1. So -1 is included. As you know, -1 gives you 2. So from -1 to, which is from here, it goes down, and it stops when it gets to 1. If you plug in 1, you get 0. So over here, it stops. So over here, you have a hold. Why do you have a hold? So I want to make sure we understand that. So it starts from here. Okay. And over here, there's a hold. This is solid because it's a equality. This is hold because it doesn't have the equality. At this point, we have the pair 1, comma 2. Then after x larger than 1. So here's the parabola. Which portion is good? First, at 1 is this point. And this point is a hold because it doesn't have the equality. So this point, which is 1, comma 1, there is a hold there. So there is a hold there, goes up there. That's the graph. So I hope everybody's comfortable with that, okay? This endpoint is included. This one is not. This one is not either. There's a solid point here. That's the graph. Now, what about the domain and range? Well, the domain clearly is from -1 to infinity. And the range starts from 0 and goes to infinity. But when you look at the bottom here, there is a hole. There is a no solid point. So 0 is not included. Remember, you are talking about which portion of the y coordinate is covered from 0 to infinity. 0 is not included. That would be the range. Find the average rate of change of f of x equals x squared minus 3x from x equals 2 to x equals 4. So basically, the average rate of change means look at one of those formulas, however you like, it makes no difference. And we have a lot of usage for that, like I said, later on in calculus. So f of b minus f of a over b minus a, or any of these formats. In this case, f of 4 minus f of 2 over 4 minus 2. That's the meaning of it. So you plug it. We get 4 squared minus 3 times 4 minus brackets 2 squared minus 3 times 2. The denominator is just. So this is f of 4. This is f of 2. Let's simplify, see what we get. 16 minus 12. 4 minus 6, which is negative. So we get 16 minus 12, which is 4, minus minus 2, which is plus 2 over 2. So 6 halves equals 3. So pretty straightforward, everybody. All right, now we are looking at the same thing, but this time we want to find the average rate of change from x equals 4 to 4 plus h. So that means f of 4 plus h minus f of 4 over 4 plus h minus h. That's the meaning. In essence, we are looking at this format. Plug in here 4 plus h. And by the way, we've already calculated this to before. You can use that or do it again. Anyways, this one is 4 plus h squared minus 3 times 4 plus h. And f of 4 is here. You can put it there. This one is a plus b squared. 4 squared, which is 16, plus 2 times 4 times h, which is 8h plus h squared. So you have those. And then minus 12 minus 3h. If you just keep it like that, this is 16 minus 16 plus 12. And one way is this way. And what it does, it easily helps you see the way you simplify if you don't evaluate this second brackets. So what is left in the numerator? These two and this. Now, of course, you have h squared, and these two add up to 5h. You factor the h out from the numerator. You drop the h, and it becomes h plus 5. Find the value of x if a linear function goes through the following points and has the following slope. So the pairs are given, the slope is given, and we know the information about the lines as follows. Let's refresh everybody's memory. Lines. Standard form ax plus by equals c. Slope-intercept form y equals mx plus b. Point slope form of a line y minus y1 equals m times x minus x of 1. Vertical line has the equation x equals a, slope is undefined, x-intercept is at a0. Horizontal line, y equals b, slope is 0, y-intercept at 0, comma b. two lines are parallel, they have equal slopes, different y-intercepts, perpendicular lines, their slopes are negative reciprocal of each other. So you can say m1 is negative 1 over m2, or m2 is negative 1 over m1, or their product is negative 1. Either way is fine. So let's write the equation of a slope. Rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So for this case would be 6 minus 2 over minus 4 minus x, and it should be equal to 3. So we will do the cross product. This would be 3 times negative 4 minus x, and this would be 1 times 4. Distribute negative 12 minus 3x equals 4. Move the negative, make it positive 12. Divide by negative 3, x becomes negative 16 thirds. So pretty straightforward. Consider this scenario. A town has an initial population of 75,000. It grows at a constant rate of 2,500 per year. Find the linear function. The linear function that models the town's population P as a function of the year T, where T is the number of years since the model began. It's pretty straightforward. P of T is the population as a function of T. The constant rate of growth of the function is M, 2,500 per year. Initially, we have 75,000 population. That represents the B. So the linear function y equals mx plus b becomes p equals mt plus b. Please understand that normally we have the independent variable x, dependent variable y, but now we are going with the population as a function of time. So replace the m, replace the b, you get P of t equals 2,500 t plus 75,000. And it's done. Part B, what will be the population in 10 years? Or what will the population be 10 years from the beginning? So replace the t with 10. So 25K plus 75K, it's 100K. That's pretty straightforward, everybody. Monthly cost of a cellular plan depends on the number of minutes used and a flat fee. 410 minutes cost 71.50 and 720 minutes cost $118. Express the cost C as a linear function of the monthly minutes used X. Normally we have X and Y. In this case, we have minutes and cost, X and C. It's important to write the variables that normally we use versus what we need to use now. So y minus y1 equals m times x minus x of 1. We have the following two pairs. From here, we have 410 minutes, $71.50. From here, we have 720 minutes, $118. So let's find the slope. Normally we use y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But now we are going to use c sub 2 minus c sub 1 over x sub 2 minus x sub, which means 118 minus 7150 over 720 minus 40. And so you simplify. The numerator is 46.5. The denominator is 310. It becomes 3 over 20 or 0.15 either way. And using the point slope, y minus y1 equals m times x minus x of 1. And we are going to write c, instead of y, we're going to write c minus y sub 1. Now we use this one or this one, okay? Makes no difference. So for example, if you use this one, y minus y1 becomes c minus 118. M is one of those two numbers. If you go with the fraction 3 over 20, x minus 720. So we use this one, everybody. Now, if you use this one, you get c minus 7150 is 3 over 20, x minus 410, but they end up being the same. In fact, you can check it afterwards. So with that being the case, you multiply these two, you get 3 over 20 times x, and you multiply these two, you divide 720 by 20, you multiply it by 3, you get 108, so minus 108. And this moves, becomes plus 118. So C is 3 over 20 x plus 10, or you can write it as 0.15x plus 10. Okay. Now, before you move on, you really should check with this one. You have to put 410 calculated and plus 10. It will give you 7150. You should check it. It doesn't take. What is the cost using 687 minutes? Put it here into any of those equations. And you can use a calculator. You end up with, scientific calculator will do $113.05. So So it's $113.05 in essence. Now the interpretation of the slope and the c-intercept. So let's go to the slope, 3 over 20 or 0.15. That is the change that happens. Okay. And this is the constant cost, okay, the fixed cost, and no matter what. So the c-intercept, instead of the y-intercept, we're going to call it the c-intercept. Represents the fixed monthly cost, flat fee charged by company, which is whatever this number is, $10. The slope is the change, that means per unit of time, per minute in this case, they charge 15 cents. So the slope represents the change in cost per minute of call for the amount of $0.15 per minute. The height in inches of a sunflower X weeks after being planted can be approximated by this function. How tall is this sunflower 8 weeks after planting? So I hope you realize this means just f of it, plug in it. Plug in it. So you get 48 minus, this is 64. 1/4 of it is 16. You get 32 inches. The units, okay, are clearly indicated. We're going to find the average rate of growth from the end of week 6 to the end of week 12. Always include units with word problems. And so we want delta y over delta x, or f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1, or f of 12 minus f of 6 over 12 minus 6. Because we go from 6 to 12 weeks. So we go back to this function and we plug in 12 minus, we plug in 6 over 12 minus 6, which is 6. So this is 72, this is 144, comes 36, this is 36. So is this one 1/4 of it is 9. So if you apply the negative, these 3 cancel each other, this becomes 9 over 6, and it becomes 3/2 of an inch per week. Units of the numerator change in height in inches over the units of the denominator change in weeks. That's the final answer.